Hoover Dam, of course, forms Lake Mead, which in turn helps supply drinking water to about 25 million people in southern Nevada, Southern California, Arizona. It also supplies hydroelectric power to 1.3 million households in those 3 states, and as Joe mentioned.
Scientists are sounding the alarm as Hoover Dam, icon of American engineering and symbol of unyielding human ambition, now stands at the epicenter of a crisis few thought possible. The world's eyes once marveled at the dam's grandeur.
Today, those same eyes watch in disbelief at an unraveling scene that upends every long-held assumption about water, security, and the very landscape of the American West. Decades of ambition are now shadowed by growing dread, as the gates that once released the Colorado River's bounty stand quieter than ever. A stark new reality rises from the water's edge. One sculpted by relentless drought, policy challenges, and a slow, silent retreat of the river itself. Hoover Dam, once viewed as an invincible defender, now finds itself on the front line. A critical stronghold in a battle against changes more profound and rapid than ever envisioned. What makes this moment so alarming is the convergence of visible and invisible threats. Water lines etched along the canyon walls are no longer silent history, but daily reminders of accelerating loss. Lake Mead bathtub rings, ghostly white scars, rise higher, marking a crisis deeper than any one drought, more unpredictable than any storm. It's not just about water. It's about everything water upholds. As new aerial footage of the reservoir's shrinking shoreline circulates, the question echoes louder. What happens when the dam built to protect becomes a warning we can't ignore? What's unfolding beneath the sun-bleached surface requires renewed attention. Forgotten fissures, shifting sediments, mounting stress with each vanishing drop. The aftermath now revealed is more profound, more permanent than any overflowing reservoir or routine maintenance challenge. If Hoover Dam could speak, what warnings would echo from its mighty foundations? And if we truly understand this danger, are we ready to accept the scientific realities waiting just beneath the surface? Dawn breaks over Black Canyon, but the world beneath the rising light is unfamiliar and deeply changed. For generations, water shimmered across Lake Mead's vast expanse, a mirror for the ambitions of cities, industries, and millions who learned to trust the promise of the Colorado River. Now, the reservoir's edge recedes visibly, almost as if in retreat. Tourists drawn by the dam's legend now find themselves not at lakefronts, but surrounded by ghostscapes. Empty marinas, grounded docks, piers collapsed into dust. The bathtub rings, those stark white bands marking the lake's former heights, now stretch further, serving as unblinking witnesses to an ongoing water loss so relentless it feels surreal. Each layer tells a story of old shorelines, former roads, and relics surfacing from the exposed mud. What was hidden is now exposed. Walking the cracked lakebed, one might encounter the skeleton of a boat lost decades ago, a car abandoned in more abundant times, or sun-dried animal bones, evidence of a landscape changed not by regular seasonal cycles, but by a drought that refuses to break. The question only grows heavier. How does a reservoir, once hailed as a lifeline, become a warning sign of scarcity? What does it mean when a superstructure built to control floods now presides over emptiness and decline? The sense of emptiness is paired with palpable anxiety. Scientists closely monitoring the region ring out their warnings. Each drop in lake level exposes more than lost water. With every vertical foot the reservoir falls, access changes, marinas close, and boat ramps extend further into nothingness. Cities like Las Vegas, long sheltered by the illusion of endless supply, now face growing uncertainty. Lake Mead's shoreline once marked the boundary between land and promise. Now it's a vanishing line, a reminder that the cost of overconfidence can stretch over generations. Behind the dramatic visuals lies an even deeper problem, rarely acknowledged. The loss isn't just above the surface. Beneath the waterline, a more complicated aftermath is taking hold. If you're gripped by the urgency of these revelations, consider subscribing. Each new discovery brings us closer to the truth. Be the first to know, and let's uncover together what really lies at the heart of Hoover Dam's crisis. As the waters withdraw, they reveal more than what was lost. They expose what was expected to remain protected. From the steep flanks of the canyon, engineers diligently survey the changing topography, noting how the anchor points for docks and walkways now hang over dry cliffs instead of water. Erosion establishes itself along barren slopes, unchecked where waves once lapped gently. Once stable canyon walls become susceptible to subtle collapse. Routine maintenance transforms into urgent response. Now stand exposed, vulnerable to air, debris, and higher temperatures than anticipated. Cooling for the dam's turbines, once insured by constant water, now faces new constraints and risks. The margin for error shrinks. Engineers work overtime to adjust power lines and vital conduits, which now sit far above where the waterline would once have hidden them. Of particular concern is intake tower number 1, famously the lowest draw for Hoover's hydroelectric turbines, now much closer to dead pool, the level where water can no longer pass through the dam. Each foot of lost water escalates concerns and triggers new contingency planning among maintenance crews. The consequences reach far beyond the immediate area. Downstream, states that once negotiated intensely over every Colorado River drop now grapple with dramatic reductions. Water managers impose stricter conservation rules, warning that previously temporary measures may instead need to become permanent. Farmers in central Arizona and southern California have fallowed more fields due to urgent allocation cutbacks. The cumulative effect is a slow-moving shockwave, felt in the everyday routines of millions who turn on taps expecting supply. Most alarming of all is the reversal of certainty. The dam, built to command nature, is being tested by forces neither fully predicted nor controlled. In this reversal, we see the true face of the aftermath, a future increasingly defined by what the dam cannot provide. Clearly, the danger does not end at the receding shore. It multiplies, echoing across the very pillars of modern life: energy, food production, and public safety. As water levels fall, a second crisis emerges, unseen to casual observers, but clear to those who understand the workings of the Southwest power grid. The dam's turbines, Hoover's hydroelectric heart, depend on a minimum head of water pressure to reliably generate electricity for millions across Nevada, Arizona, and California. That needed pressure is diminishing. Engineers and power managers have noted that turbine output has dropped by more than 30% since the onset of severe drought, a trend directly correlated to the reduction in hydraulic head as Lake Mead has fallen far below its historical average. Monitors at the power station now regularly mark new lows. The megawatt hours that once powered the Southwest fade in real time. Cities once accustomed to cheap, renewable hydroelectricity must purchase more costly power generated by natural gas or coal. We built regional growth on expectations of endless water and electricity from this reservoir, experts explain. When Hoover approaches operational minimums, we risk losing the backbone of much of the regional grid. Essential institutions, hospitals, emergency services, data centers are updating plans and infrastructure in preparation for further disruptions. An additional and unexpected pressure point comes from fluctuating reservoir chemistry. As water levels drop, minerals and contaminants become more concentrated, creating challenges for turbine maintenance and water treatment alike. This hastens corrosion and mechanical wear, forcing equipment renewals on a timeline never anticipated in the original design. The strain is not simply hypothetical. States have asked for voluntary and at times mandatory conservation. Water and electric utilities urge residents to prepare for shortages. Brief, localized power outages, often triggered by peak demand during heat waves, have already affected smaller communities. And the crisis is not abstract. In the summer months, power authorities across the Southwest raise public warnings. We're one extreme heat wave away from the tipping point. If water drops further, the question isn't if, but when large-scale power interruptions will hit. Even major cities have been forced to acknowledge the limits, a vivid reminder that here, climate and infrastructure are inseparably linked. If Hoover Dam's energy generation falters, what will anchor the region's future? Scientists and engineers are closely tracking shifts that ripple invisibly through Hoover Dam's concrete structure and its geological base. Dr. Kenji Adani, a geologist specializing in dam safety, details a little discussed concern. With every foot the water falls, the foundation dynamics of the dam change. The immense weight of pooled water behind the structure actually stabilizes both rock and concrete. As that pressure drops away, stress redistributes. In practice, this means that once submerged canyon walls begin to dry out, developing new cracks under the relentless sun and wind. Fissures in the ancient bedrock, long suppressed by pooled water, may slowly widen. Vibrations from ongoing operations, once cushioned by water, may now travel through the canyon with altered effect. At a technical level, sensors embedded throughout the dam and its foundations, some installed decades after original construction, now transmit a constant stream of data, monitoring for ground movement, temperature change, and microcracking. While the Bureau of Reclamation reports no indication of critical instability at Hoover Dam, such close monitoring is essential. Even tiny shifts, a few millimeters a year, can affect the structure's long-term performance. Maintenance teams have found small fissures and exposed seams on surfaces that, until recently, were always underwater, now requiring determined intervention to prevent weather intrusion. Concrete, robust as it is, must still contend with decades of exposure when its environment changes so suddenly. If the dam was built as a barrier against nature's forces, it now stands as a constantly monitored frontier, proof that even our most permanent works must adapt. And as the structural integrity faces fresh challenges, the question arises, how do we ensure the world's great dams endure a climate no one fully planned for? Beyond Hoover Dam itself, the landscape of water management in the West is being redefined. Farmers in California's Imperial Valley and elsewhere have watched water delivery contracts, once considered untouchable, become conditional, dependent on new emergency plans. Water allotments for counties and entire irrigation districts are revised, contracts renegotiated under the shadow of a shrinking reservoir. Dr. Amina Rael, a policy analyst specializing in river basin management, points to the new reality. We're rationing a legacy. Each piece of the water pie is now smaller, and with that, every negotiation becomes harder. Communities that once lobbied for more now must reconsider what, if anything, they can afford to give up. The visual evidence is stark. Dead orchards line fields. Thousands of trees removed not by insects or blight, but by lack of irrigation. Dust billows where green fields once grew. On the edge of empty canals, families reckon with a way of life challenged by scarcity rather than abundance. Cities are not immune. Las Vegas, Phoenix, and other regional hubs have imposed new water use restrictions, including bans on watering decorative lawns, tighter limits for hotels and casinos, and widespread campaigns to promote desert landscaping. Suburban conflicts rise as homeowner associations clash with utilities over water rights. Realty markets respond. In some neighborhoods, homes near former lakefronts lose value as the promise of scenic views disappears and water access grows more uncertain. A shrinking lake also exposes decades-old environmental challenges. Sunken relics, boats, vehicles, once submerged contaminants are now visible, occasionally prompting public health warnings. Dust storms stirred from the dried lakebed now carry fine sediment, and air quality alerts occasionally follow in surrounding communities. The crisis is not only hydrological and infrastructural, it now has ecological and public health dimensions as well. Dr. Rael's conclusion is direct. We cannot plan for a simple return to what was. The new normal is uncertain, and every year the boundaries of risk and adaptation must be redrawn. Electrical uncertainty, water rationing, and infrastructure stress. This isn't a single event, but a complex, rolling situation touching every facet of daily life. Hospitals and emergency clinics, once confident in backup power systems, reinforce their plans for more sustained outages. Telecommunications operators warn of potential disruptions as regional power becomes less reliable. Emergency management officials stockpile supplies, and local authorities establish cooling and aid stations to address extreme heat and water scarcity. City and state leaders issue public advisories: conserve energy and water, check on vulnerable neighbours, and be prepared for disruptions. Utility providers urge residents to fill bathtubs and store water in advance of extreme weather events. Community centres in at-risk neighbourhoods become critical gathering points in times of outage or shortage. Researchers studying crisis management now analyse sensors, weather patterns, and water use data to optimise emergency responses. Dr. Julia Bennett, a disaster response specialist, captures the challenge. Compound hazards are the new normal. Drought, infrastructure stress, and social strain all feed into one another. We can make repairs, but strengthening resilience is more complex. As the strain mounts, city governments often pivot from mitigation to triage, allocating resources to the neediest areas and prioritizing core functions. Emergency water distribution, public cooling shelters, and backup generation for critical sites represent the latest front in the effort to maintain social stability during an evolving crisis. Incident commanders inform local officials. We cannot guarantee fully reliable water or power. Prepare for ongoing problems. City websites and hotlines offer updates, encouraging residents to think not just of their own needs, but the well-being of all. As these compound risks cascade, the pressure mounts. One unanticipated event could force the system beyond what patchwork solutions can repair. For those who want to stay informed on these critical developments, subscribing ensures you won't miss the latest analysis, and that your awareness can help amplify the urgency this problem demands. Scientists reviewing years of climate forecasts admit that reality has outpaced many models. Dr. Nolan Reiter and his colleagues at the University of Nevada now update climate and water supply projections almost monthly. We modelled for droughts, for cyclical lows, but the convergence we see, persistent mega-droughts, human overuse, rapid evaporation, and delayed policy changes, was not fully anticipated. This aftermath has outstripped past models. The story being rewritten isn't just scientific. It challenges the foundational optimism that once surrounded Hoover Dam. Each setback raises deeper questions. If systems as fundamental as water supply and energy can falter together, what comes next? What's rebuilt when the old assumptions no longer hold? Communities are in a near constant state of adaptation. Local leaders in places like Boulder City acknowledge every option is on the table. From new conservation rules and water transfers to considering more radical shifts in resource use. We are living in real time through the future planners always warned of, just faster than we hoped, many city officials admit. Across the region, innovation and hardship go hand in hand. Some neighbourhoods band together to invest in grey water recycling and solar panels. Agricultural co-ops experiment with new drought-resistant crops. Mutual aid groups organise to support neighbours. At the same time, other communities find the burden overwhelming. Rising insurance costs and persistent water shortages drive some to relocate. Along the exposed shoreline, individuals face choices between adaptation and departure. Some undertake the challenge, experimenting with desert crops and home water systems. Others post for sale signs, migration happening not so much by choice as by necessity. All acknowledge every lost foot of water alters the region's demographic, economic, and cultural fabric. Even the national imagination is affected. Hoover Dam, once a monument to human dominion over nature, now stands as a symbol of vulnerability and a lesson in humility. The guidance for future planners shifts. Prepare for less, expect the unexpected, design systems with more flexibility. As the sun dips behind the canyon walls, shadows lengthen across the exposed lake bed. The dam's massive walls, stained and weathered after generations, appear still eternal. But those who maintain and study them know, even the strongest feats of engineering require adaptation, especially when the world beneath them is shifting. The aftermath that few anticipated is neither sudden nor singular. It marks an era, a complex transition in which every familiar pattern is revisited and every safeguard is examined. Within Hoover Dam's silent corridors, teams of engineers and scientists remain at work, continuously translating new data into interventions and contingency plans. Every day, we're working to keep the turbines spinning and the pumps circulating. Each day we succeed is another day bought for preparation, staff reflect. Yet they know these are temporary victories, not permanent solutions. Residents, farmers, and urban planners are confronting the reset as both loss and an urgent call to innovate. For some, the end of water's former abundance signals an irreversible break from the past. For others, it prompts creative action, calls for water banking, investments in river restoration, and new discussions about sharing limited resources. The dam, raised as a bulwark against chaos, now offers a different kind of lesson. Adaptation, not conquest, is the only path forward. The current crisis becomes not just a warning, but an appeal to question inherited wisdom, rewrite plans, and approach the river with renewed respect and humility. If you recognize the urgency of this story and see your own future reflected in its challenges, subscribe and join the conversation below. As we reckon with Hoover Dam's evolving legacy, let us remember, what happens next depends on both our vigilance and our willingness to learn from the new realities revealed by its changing waters. And don't miss our next episode, because the next chapter in the West's water story is being written now, shaped by what we dare to understand and remember today.